Hello everyone, today we're gonna learn some basics on nature of roots. Judging on the discriminant, which is b squared minus 4ac, we can determine the nature of the roots. This discriminant is a very important part of the quadratic equation as it helps us to determine the nature of the roots, whether the root's gonna be real or distinct, imaginary or complex, or whether it's gonna be repetitive. First, let us study the case number 1. When the discriminant b squared minus 4ac is greater than 0, then we are having roots which are real and distinct. Have you ever wondered what's gonna be the curve when the coefficient of x squared is greater than 0 for the first case? Let's look at the curve. This curve shows when the coefficient of x squared is greater than 0. It's gonna be a happy face. Since the roots are real and distinct, so the curve gonna cut the x-axis at two different distinct points. Then come to a situation when the coefficient of x squared gonna be less than 0. Then we'll be having a curve which is equivalent to a sad face. And here the same principle goes. As the roots are real and distinct, we're gonna have a curve that cuts the x-axis at two different points. Case 2. When the discriminant is equal to 0, then we can say that the roots are real and equal. Since the roots are real and equal, the curves gonna touch the x-axis at a single point. Since the roots are real, it's gonna be a tangent to the x-axis basically. First, let us look at the curve when the coefficient of x squared is greater than 0. See how it touches the curve? It's just like a tangent to the x-axis. Similarly goes for the case when the coefficient of x squared is less than 0. As we can see that it's a saddy face which touches the x-axis at a single point. Let's study case number C. When the discriminant is less than 0, we can say that the roots are imaginary or complex. Since the roots are imaginary, they are not real, so the curves won't be cutting the x-axis or touching the x-axis at any point. First, let us look at the curve when the coefficient of x squared is greater than 0. See, the happy face is not touching at any point of the x-axis, neither it is cutting it. When the coefficient of x squared is less than 0, similar thing happens. It does not cut or touch the x-axis. Combining case number 1 and 2, we can get a case 4, which is when the discriminant is greater than or equals to 0. We say that the roots are real. Thank you.